So hi, everyone. Thanks for joining us. And thanks to Mandia for giving us a talk this evening. I'm very excited for that. I'm just going to run through a couple of things, some announcements and whatnot, and then hand over to Skulk. So first of all, we just want to thank our sponsors who give us allow us to keep the lights on in terms of Zoom subscriptions, Meetup, SoundCloud, and all that kind of stuff. That is NML, who've been a sponsor of FedSA since the beginning, and IO, who joined us as a sponsor last year. And yeah, huge thanks to them. We wouldn't be able to do what we do without that support. And then we have a special sponsor this evening, and just for this evening, and that is OfferZen. And I will give you some more information about that shortly. A couple of announcements. If you aren't aware of this, there's a mentoring program that's running every Monday from 5 to 6 p.m. And if you're interested in joining that, or you know of anyone who might be interested, you can join the FEDSA mentoring channel on ZA Tech. That is run by Martin, and yeah, there's been great response to it so far, and there's some really cool stuff happening there. So if you're keen on getting involved, check out that channel on ZA Tech. And then we've got a couple of upcoming meetups. We haven't confirmed the dates yet, but we will, of course, make those live on our meetup as soon as we can. And that is, we have a Q&A with Melanie Richards from the Edge team. And she is a project manager on Edge and has a background as a developer. And she's been working on the new UI tools in Edge in collaboration with the Chromium team. So I think that's going to be really interesting to chat to her. And then we have Facundo Giuliani, who's from Prisma. He's Argentinian, and he's a Prisma developer relations advocate. And he's approached us to do a talk on creating a hybrid backend using Prisma and a headless CMS, which I think slots nicely into a lot of our interests. Well, mine and Skulk's. Yeah, so we'll announce those as soon as we've nailed down a date. Right, and my slides have stopped working. Oh dear.
Are you sure it's not the last slide?
Here we go. No, it's not the last slide. Okay, if you're unsure all the places to find us, you can find us on ZA Tech and the FEDSA channel. Twitter, we have a Twitter account, but to be honest, it's not particularly active, but we do tweet out all the events. That's at FEDSA Community. All our meetups and Q&As and everything we've done are on our YouTube channel. If you'd like to go back and look at some of those, that's FEDSA Community on YouTube. And then all our things are also on GitHub. You know, there's a whole bunch of repos on there that are open sourced, and do what you will. Right, and then finally we have an OfferZen giveaway. So OfferZen have very kindly offered the chance to win a whole bunch of OfferZen swag. And there's a form, you just need to fill in a form, and they will select some lucky people and deliver it to your house. So I'll share that link in the chat a little bit later. I don't want to do it now because everyone will rush off to fill in that form. So I'll share it a little bit later before we all run off to finish our evenings. Okay, that's it from me. Over to Skulk.
Cool. Thanks, Justin. Like, I had the opportunity to get a bit of a sneak peek of kind of what she's going to talk about today during the mentoring session at the beginning of the month. That was really great. I'm super excited about that. Like, from what I understand, she was going to add some more on top of what she presented then. So this is going to, so this is going to be really meaty. And for that purposes, we generally upload these to YouTube afterwards if you want to review it. But yeah, so I've kind of known Mandia and her husband John for a pretty long time now, and I've actually worked with both of them on projects. I know she is very much in the React world at the moment. Ben, she's working with you, if I'm not mistaken. Cool.
That's correct.
Yeah, and yeah, so Ben kind of runs Vulcan Labs, where she kind of joins him at the moment, doing a lot of React work and so forth. So I would love to have Mandia have you do a talk on some React things at some point as well. Ben has done a talk on kind of some of his React kind of best patterns and so forth. On our YouTube channel, there is a talk that he did on that. But yeah, so without any further ado, I'm happy to hand over to Mandia. She can probably give a bit of a better introduction than, hey, I work with Ben. Yeah, and you can kick us off with CSS Animation there.
Hey everyone, I'm Mandia. I'm a full-time software engineer currently working with Ben at Vulcan Labs. I specifically have an interest in front-end development, though I'm currently working as a full-stack engineer. And I really love CSS and I really love Magic the Gathering. And that's the super short summary that you'll get from me. So let's kick this off. Yeah, let's start at the very beginning. So what is animation? Animation at its most simple form is just graphics in motion. It's the visualization of change over a period of time. Now, this can take lots of different formats. GIFs are technically animation. SVG animation we'll talk about in a little bit. Flash was animation as well in those dark days. But CSS animations present a great way to bring interactivity and motion to your website. And they're really performant. They're able to make use of the graphics processor and composite thread for execution, which we'll get into a little bit more later as well. Unfortunately, I have to kick us off with a little bit of a boring section, which will be talking about the history of animation, but it's important to understand kind of what came before the things that we use now and why we don't make use of them anymore. So as I said, the very first form of graphics in motion that was really commonplace on the internet was the GIF. It was introduced in 1987 by a company called CompuServe, and one of its most popular initial usages actually was just to rotate company logos. If you were a company in the early 90s and your logo was spinning, you were on trend. So that was a little bit of a dark time, but people were really impressed by the way that a rotating logo could give the illusion of 3D. And so that was kind of the first common example of motion graphics on the web. But after that was introduced, nothing really happened in the realm of web animation for about a decade, until a technology called Flash came along. Now, those of you who are around my age probably played a lot of these kinds of Flash games during high school or maybe middle school. They were incredibly popular during the early 2000s, and there's a good reason for that. Now, before my time, there were not as many cross-platform standards as we have today, and developers had to be a lot more experimental with their approach to interactive websites and also to games. At the time, Flash was the answer to that. Now, Flash, if you don't know, was a closed source application that allowed developers to build interactivity pretty easily and run animations in the browser via a browser plugin. While the browser could interact with all of the Flash objects, it was left up to the plugin to actually run everything, which at the time made it fairly performant. And like I said, Flash was immensely popular during its time. And while it was a great technology, it unfortunately went against the core principle of the web, which was to be open and accessible. However, as the web became more mature, a rush of new specs and standards took shape. This signaled the start of the downfall of Flash, especially due to two main factors. Many of the things that Flash could do were being introduced natively in the browser, and smartphones had come along, with Apple's iPhone famously lacking Flash support. And if I remember correctly, the main reason why they didn't want to support Flash was because Flash was quite CPU intensive, and Apple had concerns about how such a major CPU processing time would affect their battery life. So fast forward a decade and Flash support has been deprecated on all major browsers, and it officially reached its end of life in 2020. Now, while Flash was devouring the web in the 2000s, the SVG standard was being built to support open vector graphics in the browser. Now, I'm not going to dig too much into this. I just wanted to mention that it forms part of the timeline for web animation. We'll talk a bit more about SVGs later, but although these weren't well supported until the 2010s, they provided the bedrock for high quality graphics and animations via both the file format and the SVG HTML element. Around the same time that SVGs were being standardized to handle vector graphics, we were also looking for ways to standardize multimedia on the web in general. Again, a core principle of the web is to be open and accessible, and a key part of that is the ability to standardize various implementations. So to handle this, the SMIL, or Synchronized Multimedia Integration Language, standard was developed. In summary, SVGs and SMIL give you the toolset to create Flash-like animations in the browser using an open standard. But it's pretty hard and it's pretty complex to get into, and it's just limited to animating SVGs, which isn't super useful for our modern purposes. So what is useful for our modern purposes? Well, as the web found its feet in the mid-2000s, one of the big leaps forward was the introduction of both HTML5 and CSS3. It's been hard for me to find clear, concrete data on the exact dates that everything happened, but this was introduced around about 2005. And one of the most anticipated features from the CSS side was the introduction of animations, transitions, and transforms and their respective properties. And that ends our little history lesson and brings us to the next section of the talk, which is the basics. So the reason why I mention a transform in this context is because I've heard the misconception quite a couple of times that transforms are in some way related to animation, but this is not actually the case. They're a very performant way to animate elements. They're very commonly animated, but intrinsically, they don't actually have anything to do with animation. So if you want to create a very basic animated element, you would instead use a transition. Transition provide a way to animate an element when changing CSS properties. They're a lot more limited than full animations, but they're also a lot simpler, making them very quick and easy to use. I'll provide a quick practical example of what a transition looks like. So you have your start state, and you need to have a state that the CSS properties are going to change to in order to have a transition. In our case, we'll make that a width of 400 pixels on hover, and you'll see if I hover over the element, it changes states. But this isn't animated. This is just a property changing states. So in order to make it a transition, we need to add the transition property. And you need a couple of core things for an animation to work. You need a timing function, and you need to specify what's going to be animated. So in this case, we want to animate the width property, and we want that to happen over a duration of 2 seconds. And that's the most basic minimum requirements for a transition. You'll see it now moves from its start state to its end state with all the intermediate changes being calculated automatically. You could also define transitions with multiple timing values. So if we wanted to go and animate its height as well, we could actually apply a, misspelled that, a different timing function to that, and we'd actually experience two transitions at the same time. There's also a special keyword called all, which will cause all properties or all animatable properties of an element to become animated when they change. Okay, so that shows us a couple of very basic points about transitions and how they're set apart from animations. So transitions require a specific trigger to run. In this case, we use the hover state. They only run once when their trigger happens. They don't loop and they can't repeat themselves automatically. And transitions only have two states that you can specify, a start state and an end state. And that is kind of what makes them so limited. So let's say a transition isn't doing it for you. You want more out of your element, or maybe you need to apply a couple of different changes at different points of the animation. For example, if we wanted the square to turn green in the middle of the transition, you couldn't do that with just a transition. So in that case, it would be more appropriate to use an animation. Now, it's worth noting that not all properties can be animated. The full list can be found in the MDN docs, but there's also a very cool demo site that displays all animatable properties. It's called Animatable, projects.vero.me/animatable, and it actually has a little example of all the different properties that exist that can be animated on hover effects. So if you're looking to see some examples of how far exactly animation can go, like look at this line height animation, you'd never think of animating that. I highly encourage you to come check out what's on the site. So to make an animation, you need to first define some keyframes that will dictate how our element should look at each step of the animation. Keyframes need at least a start and an end value. Well, not quite. They can inherit their starting value from however your element looks at the time that it starts its animation, but effectively they need both a start and an end value. They can have as many steps in between as you want though, which makes them way more flexible than transitions. You can kind of think of them effectively as the instructions for how the animation should execute over its duration. Now, there are a lot of sub-properties that you can use to define an animation, and we'll get to a couple of those in a minute. But at the bare minimum, you'll need an animation name to tell you which keyframes you're going to be applying, a duration, which tells the browser what the length of the iteration is, or the length it'll take to complete one cycle of the animation. And this isn't technically required, but you generally also want to use an iteration count, which indicates the number of times an animation is going to be performed. So that's all well and good, but let's do a quick practical example just to illustrate what I'm talking about. So we have some sneaky keyframes that we're hiding down here. So the syntax for that is keyframes, the name of the definition, its starting state, and its ending state. And we're going to apply, you can shorthand all of these properties, but for the purposes of illustrating, I'm going to actually use the full version. So our animation name is widen, our animation duration is going to be 5 seconds. And with just that, the animation should play initially whenever the page loads, but it'll only play once and then reset to its starting state. So maybe make that 3 seconds. So if I add an animation iteration count, say 4, it'll play 4 times whenever the page loads and then stop. There's also a special keyword for iteration count called infinite, which will cause your animation to just play infinitely. Infinite, yeah. Okay, I'm not going to go through all of the properties that you can possibly use here, but I do want to draw your attention to a couple of them for reasons that we'll get into a little bit later. The first one is animation timing function. So this establishes the acceleration curve of the animation. So if you've ever heard of, ease in, out, linear, or cubic Bezier, those are all ways to define acceleration curves, which just tells us how quickly the animation should execute at different points of its runtime. So most often you'll probably just use something like ease for your timing function, which I believe means it starts fast and it then gradually slows down. Then there's also animation direction, which sets the direction of the animation after its cycle. So by default, you'll see the animation reset to its starting state after each cycle. But if we wanted it to actually play backwards, alternate, we could specify a direction here. So you'll see it then plays forwards, then plays back in reverse after the cycle ends, and then forwards again. And this effectively leaves us with something very similar to the transition that we had a moment ago. Yeah, there's one more one that I want to show you guys, which I found to be very useful, for which we'll need a hover state. And that is that the actual playing state of the animation is accessible as a CSS property. So that lets you do something like this, where if I hover over the box, it stops animating. I actually, for a long time, had no idea that this was something you could control purely through CSS, but there you have it. And then one more thing before we move on from our little demo here that I want to show you guys is that you can also use CSS variables when animating. Here we have a little example of that. So here's an animation that's all in shorthand, but it's referring to keyframes by the name of change. The animation happens over 0.5 seconds. Its acceleration curve is ease in. It has a 1 second delay, which is not an attribute we mentioned. And its animation direction, no, its fill mode is forwards. So fill mode just effectively sets which values are applied before or after the animation. And if you add the forwards keyword to that, your animated elements will actually stay in the state that they were in when their animation finished. So if they were to enlarge, they'll just stay the larger size forever instead of resetting their animation. So what we have in the keyframes down here is just a scaling transformation, which is using the scale variable to apply its values. And what I just quickly want to show you guys is that you can actually utilize that to make some cool little animations. So here we have one animation, one keyframes, one definition, but because of the variable, we're able to produce entirely different effects with it, which is something that I think is really cool. Okay, so now that we've created our first actual animation, this is a good time to introduce the Animations Inspector in Google Chrome, which is a supremely useful little tool that I've made use of on many an occasion. And to get to it, you just open your DevTools. You get Zoom to stop blocking your controls. You go to More Tools, and you go to animations. And most often I found you have to just refresh the page after you open this in order to actually get it to load in properly. And what that gives you is it gives you an interface where you can actually watch your animation play out over time. Here you can see the actual acceleration curve. It starts fast and then tapers down. You can actually use this to adjust the length of the animation. You can set it to manually replay. You can slow it down. You can go through it frame by frame. It's really the most effective way to debug animations that I've found. Like, look here, you can actually drag through the different steps of the animation. So that's a very, very useful tool. Okay, let me have some water. So just to kind of recap what we've learned here. Transitions are simpler than animations, but they're a lot easier to use. You can only have a starting state and an end state, and transitions can't loop or repeat themselves in any way that I know of. There might be some fancy things you can do with JavaScript, but that isn't pure CSS animation anymore. Animations are more flexible and they can have lots of different animated steps. These are defined via keyframes. We found during the mentoring talk that you can actually, in addition to having percentage-based keyframe values like 50%, 100%, and so forth, you can actually dig down into fractions. So if you really were making some wildly advanced animation and you needed ultra super fine control, you could actually go and set keyframes at 0.1% of your animation and 0.2 and so forth. Just a little fun fact. You cannot animate all CSS properties. You should really make use of the animations inspector, and all you need at the most basic level to make an animation is to define some keyframes, apply them to an element, and add a duration. And that kind of forms the core of animation, is definition and timing. Now moving on to SVG animation. Now I'm sure almost all of you know what SVGs are, but for the benefits of those that might be a bit newer, SVGs are at the simplest level graphics built using vectors. Now a vector is an element with a specific magnitude and direction, like a line or a square. What this means is that if you're making use of an SVG, you're actually giving the browser instructions for how to draw the graphic instead of uploading the graphic itself. And while non-vector, so raster images, are a lot more popular for photographs because they have really good color depth, SVGs are ideal for illustrations like logos or icons. Because they're resolution independent, since they're instructions for how to draw something, SVGs can scale to any size without a loss in quality. They're also quite easy to edit, have a very compact file size, as you can see in the little example over here, and they're a bit more SEO friendly than traditional raster images. Now, when it comes to animating with SVGs, one major turnoff can be the idea of getting bogged down in JavaScript libraries. However, this doesn't have to be the case. CSS can handle selecting individual paths within an SVG to create cool effects. You can't animate all the properties of an SVG, but just knowing the basics can mean that it's possible to turn flat, cliched icons into something a little more impressive. So let's look at an example of that. Now, something I frequently see people searching for is a way to make an SVG appear to draw itself. These can make for some beautiful animations, and there's an easy little trick to making them that I'm going to show you guys today. So let's talk about a quick little bit of theory, and then we'll do the practical example. So the hack for a self-drawing SVG involves manipulating the stroke-offset and stroke-array properties. So the -array property is for creating dashes in the stroke of an SVG. And the higher that you set that number, the more space there's actually between the dashes of the stroke. Whereas the stroke dash offset property defines where in the SVG the dash of a stroke actually begins. And there, the higher the number, the further along the path of the SVG the dashes will begin. So how you, here's just a cool example that I had of a self-drawing SVG. This is one of my favorites. But how you actually make this has a couple of requirements. So you need an SVG that has an actual stroke, and ideally you want it to be a single line SVG, otherwise it doesn't really come out so nicely. So what we have here is an animation by the name of draw. It's repeating infinitely and it's happening over 5 seconds. And all that's currently doing is it's turning the stroke blue, just to indicate that this is actually an SVG with a stroke. Not having a stroke, just a stroke. So the first thing you need to do is you need to set the stroke dash array to a number. Now, just to illustrate how this works, we'll set it to something small, and you'll see immediately the stroke is divided into lots of little dashes. You kind of need to play around with this number to figure out exactly what the right amount is for the specific SVG that you're using. In my case, we want the dash to actually be the same length as the SVG, which is 1450. So this is actually still dashed. It's just that there's only one dash, and the dash is the entire length of the SVG. So then we need to also apply an offset so that instead of covering the entire SVG, the dash doesn't cover any of the SVG. So we offset it entirely out of the shape, which in this case is also a value you need to play around with, but for us it's going to be 1450. So you'll see there's no longer anything here. So to make it look like the SVG is drawing itself, all we actually have to do is we need to animate the dash offset property back to 0. So it'll go from being entirely off of the SVG to covering it in its entirety again. Just give it a second to recompile. And bam, it's as simple as that. So that just illustrates a little bit of the stuff that you can do with SVGs. I think you could probably almost do a whole talk just on SVG animation. So there's lots more to dig into. And I highly encourage you guys to do a bit of your own research on the matter. So you remember how I mentioned that timing is one of the core components of an animation? Well, one of the most advanced ways to manipulate timing is through a cubic Bezier function. I actually have a little code pen for this as well. It's this one. So all of these boxes have an animation applied to them that has a duration of exactly 3 seconds, but they all look as if they animate over different amounts of time. You'll see each box accelerates differently as it progresses through the animation, and this is what creates the illusion of differing animation lengths. Now, a cubic Bezier graph consists of 4 points that are used to draw a curve, and the first point will always fall on the bottom left of the graph, and the last point will always fall in the top right. This leaves us with control over the second and the third points, which slightly misleadingly here are called point 1 and point 2. And on a scale of 0 to 1, we can specify the XY coordinates of the second and the third points, which is how we generate various timing functions. So for example, here We see the timing function for ease, which was the timing function that we applied earlier to our little cube. And you can see here the graph is very steep at the start, which means that the animation accelerates quite quickly when it starts out and then gradually tapers off as it reaches the end. And there's quite a lot of math involved with making cubic Bezier functions, but do you need to actually understand all of that math to make use of these? And the answer to that is not at all. There's a really nifty site that allows you to visually construct and compare cubic Bezier functions. I didn't pre-open this one, but just to give you guys a quick demo, here we can make our ease function, and you can actually compare these to different presets. And then you can kind of play around with that to make your timing function. So here you can see we have a function that accelerates quite quickly at its start and at its end, which produces quite a jumpy motion. So that's cubic Bezier, and I also highly encourage you guys to dig into this. There's really a lot that you can accomplish with it. I didn't want to go too deep into the math side of this, but there's a great CSS tricks article that really digs deep into exactly how cubic Bezier works. So next topic, something that I don't often hear mentioned when discussing animation in general is accessibility. Now, it is possible to make web animation accessible. It just requires a bit more of a strategic approach to examine how animations contribute to the overall experience of using a website. This is where the Web Content Accessibility Guidelines, or the WCAG, come in to help. While context is important when considering accessibility, the WCAG provides general recommendations for animated content and interactions. These include pause, stop, and hide. And the intent for this is to avoid distracting users while they're having their interactions with a web page. It applies to any content that's moving, scrolling, blinking, or auto updating. And failing this criterion can cause quite a lot of problems for screen readers. Now, some examples of fulfilling this successfully would be something like a form prompt that blinks an arrow near the submit button if the user finishes filling out the form but doesn't hit the submit button, but the blinking stops after 5 seconds. So that fulfills the success criterion because it falls under point 2. Another example of successfully fulfilling this would be a loading animation. So let's say you have a preloader that's shown on a page that requires a certain percentage of a large file to be downloaded before playback can begin. The animation is the only content on the page and instructs the user to please wait while the video loads. Because the moving content is not presented in parallel with other content, no mechanism to pause, stop, or hide it needs to be provided, even though the animation may run for more than 5 seconds if the file is really big or the user has a slow internet connection. The next point that the WCAG comments on in regards to animation is 3 flashes or below. And while the WCAG does provide details on the size, ratio, and viewing angle thresholds under which flashing the screen would be considered safe, for most of us, it's best to just avoid anything that flashes more than 3 times in 1 second. To be honest, I can't really think of that many situations in which you really need to be flashing content. Maybe if you are making a video game themed or a very glitchy style website, you might run into that situation, but if you are going to use excessive flashing, consider also presenting users with the option to disable animation or to view a text-only version of the site. Then we have motion animation, which just refers to any animation that's used to create the illusion of movement. This doesn't include color, opacity, or blurring, and it can cause people with motion sensitivities to become physically ill. So this is definitely something that you need to take seriously when you consider the accessibility of your site. And the last one that the WCAG comments on is the prefers reduced motion media query, which I didn't actually know about until I started prepping for this talk. So this is a media query that accesses a setting that users can specify on an operating system level. So you can use it to specify alternative animations, maybe disable animations, have them in a pause state, or just build alternative effects to show users who've activated this setting. And this is just an example of how it works. It's just a media query, and if reduce is true, then it'll be active, and whatever you put in here will display. Okay, let me quickly check for questions before we continue.
So there's a couple. Most of them have been kind of answered by people in the chat. So there was just one around a link to one of the examples you shared, which Justin just shared in the text chat. So I just see Douglas asks, how can I check if an SVG is a single line? Not 100% sure what he means by that. So Douglas, I don't know if you maybe want to kind of expand a bit there, what you mean there. Yeah, I think that is about it. Yeah.
Okay.
Otherwise, you can continue.
No worries. I'm happy to, we're actually almost done. Performance is the last section, so I'm happy to wrap up and then we can do a big Q&A session at the end.
Awesome. Okay.
So performance is actually my favorite section of the talk. Hope that doesn't make me too lame. But to understand the performance effects of CSS animations, it's crucial to understand the rendering pipeline of the browser. Now, the rendering pipeline refers to the different steps that the browser goes through to generate and place content on a web page. So first, I didn't actually include the step here, so you can think about it as kind of a step 0. So first, JavaScript is parsed along with the HTML needed to construct our DOM tree. Then styles are calculated or recalculated. All kinds of style sheets are parsed here. The render tree is built. The render tree contains DOM tree nodes that are going to be displayed. So at this stage, the head tag is excluded, as well as the style and script. At this point, elements with their CSS display property set to none are also ignored. On the other hand, pseudo elements such as after and before blocks are included, and every text line becomes a single block. Then the layout step happens, also called the reflow step. This is where a collection of blocks generated from the render tree or are generated from the render tree. All of the block dimensions that are dependent on each other are calculated. So this is where, I don't know if you've ever heard of people referring to the phrase that everything on the web is just a block. This is where the blocks actually get made. Then the paint section happens. The rasterization of the blocks and the texts happens here. Image decoding and resizing also happen during this step. And then finally, we have the layer composition, where the composition of all the visual layers that can be processed and painted independently happens. So in reality, some of the steps that are mentioned here happen in parallel. For example, CSS and HTML parsing may contain some parallel steps, since HTML documents contain various styles and style sheet links. So it makes sense to perform some DOM and CSS object model processing in parallel. But why is this important? So it's important because animating different properties causes different sections of the pipeline to rerun. If you animate a property that triggers the layout stage of the pipeline, for example, margin, then both the paint and the composite stages have to rerun after you make your change. This is because changing the margin alters the geometry of the element, which may affect the positioning of other elements on the page, which requires the browser to perform layout calculations, which are expensive. It also triggers our pipeline. So instead of changing the margin of an element to move it during an animation, you could instead use transform. Transform is one of only two properties that only trigger changes in the composite stage of the pipeline, the other one being opacity. So you should try to stick to these two in your animations as much as possible, but they can't accomplish everything. So there is a neat little website called CSS Triggers that shows you what stages of the pipeline each property affects. It looks like this, and they give you a little guide at the top about whether this affects layout, paint, composite, and so forth. It's very well laid out and with very easy to understand explanations. So highly recommend. Another thing to consider is that CSS-based animations are typically handled on a thread known as the compositor thread. This is different from the browser's main thread, where styling, layout, painting, and JavaScript are all executed. This means that if the browser is running some expensive tasks on the main thread, then your animations can keep going without being interrupted. There's a lot of depth to this concept as well that I'm mainly skimming over for the sake of time, but maybe someday we can do a talk just on CSS performance and we can really get into this. All you need to understand for now is that CSS animations run on the compositor thread, and that can keep them flowing while expensive calculations are happening elsewhere. So in summary, if you must use a property that triggers layout or paint, it is unlikely that you'll be able to make the animation 100% smooth and high performance, that being running at a full 60 frames per second. So that about wraps it up for what I have today. There are many more topics to explore around animation on the web, especially when JavaScript gets involved or you move into the 3D space. But I decided to stay away from those for now and just do a more pure CSS focused talk. So if anyone wants to contact me, they can do so on ZATech at Mandia Roux or via my email. Or if you want to work with me, please also drop a message. We at Vulkan Labs are always on the lookout for good developers if you want to come have a fun time doing React and TypeScript. And yeah, also if you want to play Magic the Gathering with me, I am available. Please do not hesitate to contact me.
So I see there is a question there. There's specifically a question from Martin that says you have 100 layers that are stacked and all have the same background color. Are there layers behind the main layer all being rendered, ending up in extra processing power being used, or does it know to not render out the other layers?
Ooh, I'm actually not 100% sure about this one.
Yeah, so I can maybe speak a bit to that. So mostly these differ per browser. You know, like browsers have different rendering engines. So they, for what it's worth, just as a kind of an aside, they're actually rebuilding the entire Chrome rendering engine from the ground up over the next couple of years. But so yeah, it depends on the rendering engine. In my experience, specifically when it comes to reflows and things, because just of backward compatibility and so forth, it usually takes the less performant option when given a choice between a performant option and not. So what happens, so the real problem with reflows specifically, so Martin, what you're talking about is repaints, but the real problem specifically with reflows is even if the end result is the same, it still needs to do the calculation. So for example, if you change margins and padding on your layout, and the end result actually ends up being exactly the same. So for example, if you take one margin away at the top and add it at the bottom, like essentially the height of the thing is going to be the same. Regardless, like the browser still needs to do that calculation to reach kind of the conclusion that it's the same. And that's kind of what's sucking the processing power. It's not the actual outputting it on the screen. So my guess is, in your example, obviously, we're speculating here, given that it's not an actual real example, and obviously I don't have all the context of what you have in mind, but I would say in that case it would actually calculate all of them, and then only kind of at the end realize, oh, the change is actually minor, or there's no change at all. Generally, you want to err on the side of not even doing those type of things in the first place. Yeah. I don't know if anyone else can add to that.
If I can quickly jump in here, with that example, yes, literally all 100 layers have to be rendered and drawn. And the reason for that is opacity and transparency, which Mandia kind of touched on in the talk. You literally need to draw them first because something might be opaque, something might be transparent. And remember that a div by default is transparent.
Yeah, and also keep in mind that the web wasn't initially created for kind of these type of two-dimensional layouts. What it was intended for is more along the lines of what we would think of as like Google Docs or Microsoft Word. So it is, like there's only so much optimization that you can do for a medium that wasn't actually intended to kind of do like a lot of animation and kind of what we would consider with kind of modern day like GPUs and things. Yeah. So so to answer your question, Martin, unfortunately not. Like it's gonna have to like kind of process each and every one of those 100 layers. Oh, I see Justin just mentioned about a great talk from DevConf. Oh, who is it by?
It's by Anna Migas. She's from Poland.
Great.
Eastern
yeah,
Europe.
I'm definitely going to check that out. Yeah, like I've kind of over time kind of realized that if a page is really slow, like absurdly slow, and you don't know why, it reflows. It's those damn reflows and repaints. Yeah,
Definitely.
it's so easy to accidentally just trigger them, and because like it isn't like you can trigger them even when something isn't being changed. I know that there are cases where just checking the height of something with JavaScript actually triggers a reflow. I think it's if you get the bounding client or something like that. So yeah,
that talk I posted the link to from Anna. Actually, she covers so many instances in which what triggers a reflow. It's really, really fascinating. Awesome. Things you would never have thought of, like actually trigger an entire repaint of the page. Yeah. So if you're interested in that kind of thing, I really recommend checking out that talk. It's really, really great.
I know Paul Irish also has some amazing videos on these type of things.
Yes, true. Yeah.
Cool.
But I thought I would share that one because it was,
South
local.
African. Yeah. Cool. Any other questions?
There was another question from Martin around 3D content within, and is CSS preparing in any way for 3D rendering of any kind? I mean, I know there are a couple of things you can do with 3D transforms and things, but perhaps you have some insight on those.
So I guess it also depends on what you mean by 3D, because essentially when we talk about 3D, we're essentially talking about emulating 3 dimensions, because the screen
Yes.
only has 2 dimensions. So you're emulating 3 dimensions by means of skewing things and so forth. So I'll find a link now. There's actually an example of someone that built, I mentioned it in my Jamstack talk as well, that built like kind of a first-person shooter in CSS alone, which is insane. And it's one of those things like he obviously didn't ask whether it should be done before he asked whether it can be done, but I will share that. And it's like full on. You can jump, you can climb on top of things, you can go up and down stairs. It's like a full-on like first-person shooter game, although it only has just one room, but it's completely just CSS, no JavaScript. So it's just absolutely crazy what you can do. But I think there's also another kind of topic there in terms of so one thing that I actually is worth mentioning, and I'm curious whether anyone else knows this, is that sometimes I don't know if anyone has seen when they're animating text, that sometimes while it's animating, like it just becomes super weirdly rendered. And that is because it switches from CPU rendering to GPU rendering. And like you could like, and I don't know who's familiar with the will animate CSS property. And yeah, like there's like, if you're curious about kind of like that type of thing, I thought it's maybe just worth it kind of throwing it out there. Like will animate or will change, sorry, not will animate, will change. That kind of helps kind of resolve that issue. It kind of helps control a bit like when something's rendered by the GPU, when something's rendered by the CPU, and so forth.
Yeah, that's a great thing to mention, Scott. It's very useful, that.
But will change is almost like a talk in itself. And I remember back in the day, people used to do weird things with like what was it? No, it wasn't Z index. It was transform Z or something.
Preserve 3D. Yeah.
Yeah.
The hack for WebKit only. Yes. Yeah. Was it Preserve 3D or something? I can't remember. I've used it a million times. To stop that kind of jank.
Yeah. And it's one of those things, like the deeper you get into animation, the just CSS animation alone, the crazier it just gets.
There's another question, Mandia, from Arthur. This is a great one. It's also something I've always wondered about and never really, let me just say, I have been curious enough to actually find the answer to it. So I'm glad I'm maybe getting it now. Why does the transition property always go on the main rule declaration rather than the hover declaration? So when you do a transition via hover, you put the transition property, you don't put it in the hover pseudo class. You put it on the whatever you're transitioning. Is there any particular reason for that?
I haven't actually come across anything that speaks to that in my research for this talk, but I would estimate that part of the reason would be that you want to try and keep your declarations with your starting state. So keyframes very much tend to do that as well. So my very much estimate would be that that's probably why.
Right, that makes sense actually. Because then if you're making changes elsewhere, you're not losing that whenever you do that, right? Yeah. I've always also wondered about that, because it does, as Arthur says, seem slightly counterintuitive that you're making the change on hover, but you're declaring the change outside of that. Yeah. But that makes sense that it's kept in that scope. Yeah.
So I'm curious, Mandia, whether you have experience with like green sock and those type of things.
I was going to ask the same question.
No, I saw them come up while I was doing research, but I decided that I wanted to try and stay a bit more focused with the talk, because a rabbit hole that you could do a whole talk on by itself.
Yeah, I actually go ahead, Justin.
Sure. Thanks, Kalk. So in all the examples you did, you triggered your animations via CSS, right?
Yes.
Unless, yeah. What's your feeling on triggering them via JavaScript? Is that like, let's say on click, for example, on a click function or something like that? Does that give performance issues? Is it, or should you always go for the CSS option if you can?
I think it depends a bit on what exactly you're trying to accomplish. Obviously, JavaScript affords you a lot finer control over when exactly your animation gets triggered. And I think if you're trying to do something sufficiently advanced that it makes that level of control required, you don't really have any option other than to go with JavaScript. Pure CSS is nice where you can use it because it's very performant. It makes use of the GPU layer. It makes use of the threading stuff, and it keeps the complexity down, which is actually what I'd say the main benefit is if you just have one CSS property defined over having to write a whole bunch of JavaScript, I think that keeps the kind of cognitive load of your application down.
Right. Thanks.
The other thing is as well, yeah, so the other thing as well to keep in mind there is, you know, what CSS animations do afford us is that you're able to kind of sidestep the single threaded event loop of JavaScript. So the problem is if you trigger those things with JavaScript, then if there are any other events running in JavaScript, that's currently taking up that thread, it needs to wait for those to complete before like that is triggered. And you know that might seem kind of not a big issue, you know, a lot of kind of things resolve within milliseconds, but I've often found that especially when it comes to hovering and clicking somewhat, yeah, sure, but hovering specifically, like a little bit of lag is really noticeable. I don't know what it is about hovering, but any kind of mouse over, mouse out, I found that even like 100 millisecond lag, like really, it just feels off. And I think it's because it's kind of at odds with how we kind of experience the material world around us. But yeah, it's like for hover and those type of things, I would try and stay within CSS as far as possible. Clicks and those type of things tend to be a bit more forgiving. Yeah. Another thing that I also found interesting is that you can actually set a delay on transitions. And I never, well, I knew that, and I never really kind of understood why you would want to do that. It seems super counterintuitive. And then I kind of realized, you know, like probably the main reason why you want to do that is kind of those menu items that show up over hover. And if your mouse just goes like a little pixel outside of it, it goes away. So you actually want to debounce that. So that means that you're effectively debouncing things by setting a delay on the animation before the actual menu starts disappearing. And for me, that was kind of like a moment, because up until then I've done like loads of crazy weird things where I've had like an invisible div behind it that kind of serves as a general kind of like hotspot area and things. Yeah, and I think that's kind of the thing with like these animations and so forth. You showed that example of all the kind of types of animations that you can do, is because it's like the tools that it gives you are so atomic and low level that you don't really understand what are all the things you can do with these until you actually see how someone kind of co-configures all of them together, and then you're like, oh, okay, you could actually do this. So I think one for me is with the curve, you can actually have the curve go beyond the end state. So that means that if you're saying that something has to animate one, like let's say 100 pixels down, and you have the curve go over the end state in terms of higher, then it actually goes past the end state. So you can have something animate where it kind of goes past the end state and then kind of reverses back in a bit, which kind of gives you that bit of like a stretch, like kind of rubber banding effect, especially for things that are kind of like popping up. So they're like popping up and then they're kind of like slightly sliding back in, which I found like really neat. I never realized you can do that. Yeah. So in general, Mandia, I'm curious whether you have any specific tips that you can give for anyone who's working with animation.
Probably one which comes to mind is that you can accomplish a lot through transitions. And I think that often people reach for keyframes and more complicated animations before they really have to. So I would highly advise that when you're making your decisions regarding what animation to use, first consider if maybe you could use a transition instead. Again, it keeps the cognitive load of your application down a little bit. It doesn't really have much of a performance difference versus animations actually, but it can just help keep things a bit simpler. So just think about that when you make your decisions.
I think one thing that I find really great in terms of transitions, especially coming from, as you mentioned, kind of like the Flash world and so forth. I remember something I was super rife within kind of the world of Flash animation is that an animation needed to complete before a new one could start. So if you, for example, have a hover effect where if you hover over something like a menu expands, but if you move away in the middle of that effect, it needs to complete first and then it needs to expand back. Whereas what's really nice with transitions, like if it starts expanding and you move your mouse away, then it just goes back like from where it was immediately. It doesn't go through the entire animation and then like close completely again. So I think that's what I really like about transition as well, which is something that you don't get with keyframes. Because transition is super declarative. You're essentially just telling the browser, like, these are the two states. You figure out how to make it work. You figure out when it needs to be and how it's going to get to that state. Yeah, I think, as I mentioned, coming from kind of some of the more old school tools, especially things like kind of the animate with jQuery and so forth. I know there's some of you here that still do animation with jQuery, that trusty animate method. But yeah, like coming from that world, like transitions are just amazing in terms of just how declarative they are.
And the performance benefits over animating in JavaScript are immense. Yeah. If you use, as you said, transforms rather than height or width or things like that. Yeah. Or heaven forbid, margins.
So I see there's a question, and Justin, maybe you can speak a bit to this because you're kind of the resident web font expert. This is a flash of unstyled text.
Use an SVG.
Yeah.
This is this look, we still haven't solved. This is one of my areas I know a little bit about. We still haven't solved FOUT, and we're not going to anytime soon. So yeah, you'd have to do some check to see if your font face is loaded before you trigger the animation. Yeah, it's a tricky one. Yeah, or I mean, yeah, you could. I suppose you could delay it, cache the font face, or you could inline the. You could, if it was just for a particular element that isn't likely to change, maybe a logo or something like that. You could just load in the characters and glyphs that you need from that particular font and inline them as a data URI. That would be your best option. Yeah, that might get rid of fart. Yeah,
so,
but you need to make
like
that file. Yeah, base 64. It's yeah. But you would need to really remove every single glyph from that font file that you're not going to be using. Yeah, to make it as small as possible, and then if you inline it like that, yeah, it's still gonna. You still might have problems. You would also want to preload it using the preload attribute above your CSS file, and then you might get away with it, but no guarantees. Yeah.
Why not chuck in a service worker while you're at it?
Yeah, no, that would help, but only the second time you come to the site. Your first hit is always going to be an issue. Yeah. No, always put your font files in your service worker, but that's there's always a first time.
To be honest, like given that we're talking about service workers now, like I'd be curious what is preventing you from just using an SVG that makes a service worker sound like a more attractive option in terms of like solving your animation issues. Yeah, but yeah, like in general, I actually find that like that is something that's very kind of underutilized. A lot of times people pull in an entire font face just for like a single like title or something that's in a different font. I usually just create outline in Illustrator and just pull it in as an SVG.
I saw an article once with someone pulling in an entire font face because they liked the ampersand.
True. Sure. Fun times. So
we're getting a bit off topic. that's another talk.
So I see Justin. John asked about like whether there's a way that you can check that in CSS. So the problem with CSS is, like CSS by nature of not being imperative in the way that JavaScript is, has kind of no sense of time or temporality. So there's no sense of do this when that. There's no concept of time lapsing in CSS. It's just completely declarative. You just provide it in the same way you would provide like XML or whatever, and the parser just turns that into kind of like the CSS object model. So unfortunately, there's no concept in CSS of waiting for something to happen. That you're going to have to be like the engine itself doesn't allow for that. So there's not even going to be some crazy hack or something that you can do. So you're unfortunately going to have to be reliant on JavaScript for that. Yeah.
We're still a little bit off topic here, but I just want to quickly mention that there's a new spec proposal for subsetting fonts in CSS. So instead of I posted a link to Glyphhanger, which allows you to subset and just pull out the glyphs that you want. We're going to be able to do that with native tools at some point. So within your font face declaration, you'll be able to just say only use these glyphs. But it's still a long way off. Yeah.
I hope you guys are happy now. You got Justin started on web topography.
Okay, I will. I'm going to stop now.
Now we're going to have to be here for another 2 hours. Well done, guys.
Have you heard my opinion on Roboto?
Yeah, it's the best. Yeah. Cool. So I just want to see, are there any other questions regarding animation?
Skulk, if there aren't any other questions, could I be very presumption and say something brief about Vulkan Labs? No is an answer. We're not a sponsor. Justin, you okay with that?
As long as you can guarantee me that Mandia worked on this talk during billable hours, then like that is your sponsorship.
Some of it, yeah.
Like that's your donation then.
Yeah. Thank you. So a lot of things are important to us. Nothing as important as continual learning. So this kind of talk happens literally daily at the end of the day at Vulcan Labs. I shared a link to our staging site, long story. Hiring for all roles. Talk to Mandia on ZA Tech at Mandia Roux or Michael Burtis at Boats. I'll drop my email in the chat, and I'm Other Ben on ZA Tech. Thank you so much for attending this talk and supporting us.
Great stuff. Yeah. And I did mention, like, Ben did a phenomenal talk on React as well. So you can have a look at our YouTube channel if you want to check that out.
Yeah, seconded. That's really worth your time.
Cool. So I see Justin just dropped the offers in type form. So for those of you that are still around, you can go score a t-shirt. Yeah, now we're going to see people drop.
Just waiting for that.
It's like, yeah, cool. But yeah, I will see if I can maybe upload a video of this maybe tomorrow. I will share it on Meetup. Yeah, I don't know if you maybe have anything you want to say in closing, Mandia, or whether anyone wants to kind of pop a super quick last question. Yeah, John.
Just thanks for having me, and I hope that you guys see me here again sometime.
All right.
Yeah. Thanks so much, Mandia. That was really fantastic. And yeah, we will definitely see you here again.
Yeah.
Cool. Yeah, that performance talk, I think, would be really, well, that you mentioned talking about performance would be amazing. Yeah, but we can have that discussion.
Yeah, that's probably going to have to be several speakers because there's just so many things to touch on.
A series.
Oh, yikes. Okay. But yeah, maybe from my side, just in closing, we're always looking for speakers. So Justin mentioned that we have a couple of live Q&As coming up. Some of them are pretty high profile, but like we actually prefer just having local people share. And also like, I think one of the things that we don't get enough of is like juniors and people just learning things, kind of sharing their experience. People tend to think you need to really be an expert in something. So like, even if you're kind of like still new to web development, or you're interested in maybe learning some specific tech, and you say like, hey, I just want to do a dive into this and maybe give a talk in terms of what I learned and so forth, please do reach out to us. We're always super happy about like kind of having people do talks, and we are even keen to maybe help you kind of refine it a bit if you need some help and so forth.
Yeah, absolutely.
Cool.
Seconded.
Cool. I see Leandri says yay for juniors. Yay for juniors. They keep the web running. Yeah. Cool, everyone. Have a phenomenal evening and have a great weekend. And we'll all chat soon again.
Thanks, everyone.
Thank you.
Cheers.
Bye.